for assessing abundance in British Columbia.
Sorry, that was a mouthful for a title. Hi everyone, today I'll be talking about some of my thesis work on steelhead recreational fisheries in British Columbia. So recreational fisheries are complex systems with feedbacks among fish populations, managers, and anglers. And there's growing awareness that the successful management of these systems should take into account regulating human activity across potentially vast and ecologically diverse regions. And steelhead fisheries in British Columbia exemplify some of these dynamics. BC is on the west coast of Canada, pictured here on this map. There's over 400 steelhead-bearing streams in the province across these different management areas. A couple of the key systems are highlighted here, and they're one of our top sport species. There's over 21,000 anglers annually, and in 2022, anglers spent 122,000 days fishing for steelhead and over $51 million in expenditures for the species. However, the fishery is changing and it's hard to manage both fish populations and pressure from anglers that have diverse behaviors, skills, and preferences. So we have a wide range of fishing opportunities. As you can see, on the bottom here is one of our hatchery systems on the Vedder River. And then we also have these comparatively unaltered systems, which are more remote in northern BC, like the Skeena here pictured. We have both summer and winter runs of steelhead, so people can fish for steelhead throughout most of the year. One of the most iconic summer steelhead runs is that of the Thompson River. It once hosted a renowned recreational fishery for steelhead. However, the population has declined by over 80% since the 1990s. And despite increasingly strict regulations and the eventual closure of the fishery, the population has yet to show signs of recovery. Now, these declines aren't unique to the Thompson. Steelhead have been declining across the range over the last 40 or 50 years. These are just a couple of the papers that are highlighting some of those declines. And it's a challenge to understand how anglers have redistributed their effort following changes to the fishery and also in relation to other factors that impact their satisfaction. So this is just a map of British Columbia showing angler effort. So that's just days spent fishing, where each point represents a stream. And areas with higher angler effort are larger and lighter dots. And each year has been overlaid here. So if you think of the other slide that I showed you, we have the Vedder River, which is the hatchery run, which has some of the highest effort in British Columbia. And then we also have a lot of lodges in more remote areas, such as the Skeena. So two questions that I was interested in for some of my work was, one, how has angler effort for steelhead redistributed over space and across time in the province of BC? And also, which kind of factors are driving some of these shifts? So the data I used for angler effort comes from the Steelhead Harvest Questionnaire, which is pictured here. This is a mail-out survey which was initiated in 1966 to quantify provincial catch and effort data. It spans over the 400 steelhead streams, and in most cases this is the only available data on steelhead. To examine some of these questions, I used a spatio-temporal generalized linear mixed effects model using the SDM-TMB package. So my response was total angler days per year and per stream. And then I also looked at several catch and non-catch related factors that might affect angler effort, things like time, the proportion of hatchery fish in a given stream, whether it's summer or winter run, the size of the stream, human population density surrounding stream, certain classified water regulations. So these are especially managed areas for steelhead in areas that are productive, and then also rolling average of catch per unit effort over 3 years. And then I also included spatio-temporal random effects of each stream. So the study included 214 streams in the province. All right, so now getting into some of the findings. First, I'll look at some of the spatial shifts in angler effort. This is just a map showing the center of gravity of angler effort over space and time. So just where your average effort would be concentrated in a given year, and uncertainty is shown with the surrounding range bars. And here lighter years represent earlier years in the time series. And as you can see, angler effort has shifted around a lot. In the late 80s, there was a northward shift, followed by a subsequent shift south in the 1990s and 2000s. But there's really been a resurgence north since 2010. And overall, the trend we see is this northward shift. And this is just a map showing predicted angler effort for these different streams over time. So darker dots represent areas with higher angler effort. And what we find is that while some areas have remained consistent hotspots for steelhead angling, others have disappeared entirely, like the Thompson River I was mentioning earlier. And then conversely, we have new fisheries that are opening in other areas, specifically in more remote areas of the province. Angler effort has also become focused on fewer streams over time. So this is evidenced by the Gini coefficient. And what we're finding is there's increased inequality in angler effort over time. So this is just a figure showing the cumulative proportion of streams versus the cumulative proportion of angler effort. And to highlight this, the 10 most popular streams supported 46% of angler effort in the 1970s, and this number increased to 69% in the 1990s. So getting into some of the factors that might be driving shifts in angler effort, this is an effect size plot for the some of the model coefficients where positive values indicate increased angler effort. I'll just highlight a couple of the key ones. So first, what I saw was that there's a decline in angler effort over the studied period. And this is also reflected by license sales. So there's about half the number of licenses sold in 2007 compared to 1988. Stocking also influenced angler effort. So streams with hatchery origin fish could experience up to 80% higher effort compared to streams with wild fish only. And then angler effort also increases with catch rate, albeit a smaller effect size. Okay, so taken together, I am seeing spatio-temporal shifts in angler effort. In general, we see a northern shift in effort, and effort is becoming focused on fewer stream. And it's influenced by both catch and non-catch related factors. There's this idea that recreational fisheries might have the potential to self-regulate. However, this can be broken down when people are interested in non-catch related factors, some of which I mentioned earlier, and then also when there's a disconnect between how many fish there are and how many fish we're catching. So that's the next part of my work that I'd like to talk about. So while it's not uncommon in fisheries science to assume a linear relationship between the number of fish you're catching and fish abundance, this relationship can often deviate from linearity. So in instances where catch declines more rapidly or less rapidly than abundance are categorized as hyperstable. So we only really detect declines when the population is at really low levels of abundance. And at this point, conservation measures might be difficult, if not impossible. So this has been studied a lot in marine fisheries, but also in recreational fisheries. This is a study by Dassow and others that manipulated experimentally the abundance of largemouth bass, sorry, and they found that anglers have similar success whether there was 350 fish or as few as 50. So it's important to figure out whether this is happening in the province of British Columbia because, as I mentioned earlier, the main type of data we have for steelhead are these catch data. So what I did was I compared the few areas where we do have fisheries-independent monitoring to the catch data. So that included 14 different streams across the province, which are pictured on this map here, across 5 management regions. And these fisheries-independent data came from the Pacific Salmon Explorer platform, which is by an ENGO called Pacific Salmon Foundation on the west coast of Canada. And then those catch data came from that mail-out survey that I was mentioning earlier. So what I found was that the relationship was strongly hyperstable across all 14 streams. So this is a figure showing the global slope of the relationship in gray with confidence intervals, and then each stream here is pictured with the raw data. So what we're seeing is that there is a disconnect between the number of fish that anglers are catching versus the amount of fish that we're actually seeing. There was, however, considerable variation in the relationship between catch per unit effort and abundance. So this is just showing that global slope of the relationship across the different streams. While it was beyond the scope of the study to look into some of these some of the causes of this hyperstability, a couple common ones are effort sorting. So skilled anglers are likely to continue to have catch success and stay in an area longer if they're catching a lot of fish, whereas less skilled anglers might leave the fishery or go to another spot. And also steelhead aggregate, and we're good at finding them. So those are some of the reasons that we might be seeing this hyperstable relationship. I also ran a couple of simulations to assess how the global level of hyperstability might affect our ability to estimate true abundance. For example, I found that when steelhead declined by 50%, catches only declined by 40%, and this overestimation only increases at lower population levels as well, which is concerning. All right, so taken together, I find evidence of hyperstability for steelhead in British Columbia. And this means that the recreational catch data that we have alone are likely insufficient to assess steelhead health and status. And it is concerning because the 14 streams that I include in the study are the areas where we do have data, so it might be more widespread across the province than we think. And tying this back to earlier work, it might also affect the fishery's ability to self-regulate. Oops. All right, that's it for me. Thank you.
Thanks, Julie. That was awesome. Very interesting. I got a question. There's time for questions. We got lunch coming up. So I was curious, do you think there is any indication of effort creep in the angling population? Are they getting better? I mean, yeah, are they getting better at catching steelhead?
Yeah.
Have techniques changed a lot? I'm sure they have. It's a constant issue in analyzing any catch per unit effort data. But I was just curious of what, because it does seem like there is hyperstability going on.
Yeah.
And effort creep is often a way to sort of explain that.
Yeah, I think, there's a couple things. I wasn't able to look into those, but just from talking to people, I mean, obviously there's been improvements to gear over time, so that might contribute to hyperstability. I think there's also probably better access to information as well than there were before. And then also BC has had a lot of development in terms of access and lodges and stuff like that. So yeah, I think it's what drives hyperstability in specific areas is probably could be different, but yeah, there might be.
It's very interesting. It's definitely an issue we've seen in South Africa, and we've also got some assumptions about, especially fish that aggregate. The use of social media definitely does seem to increase effort in specific areas where, as aggregations form, anglers get onto it very quickly and hammer it hard, even if aggregations only last a week.
Yeah.
So, yeah.
I think there's also the conservation risk. People might be shifting areas based on that as well. A lot of our southern stocks are not doing as well, so we might see
I mean, information
so
sharing
make
in
sure space
general,
them out.
if people are saying we aren't catching any fish in this stream,
Mm-hmm.
nobody's going to go there.
Yeah.
Where in the past they would still go try, have a day or two because that if maybe they only speak to one or two, don't trust them, etc. So yeah, very interesting, really cool. Yes.
Just a quick one for me. Relates to the first part of the spatial stuff.
Mm-hmm.
Just curious why you didn't include something like human gravity as a random variable. You know, surely effort changes, you know, with human gravity, with population size.
Mm-hmm. Yeah, I did include human population density, but I did it like for each stream, I included kind of like a radius.
Okay.
Where I was putting population density, and the relationship is non-linear because you can have areas like hatchery streams where you have like high population density, high effort, and then you also have areas like lodges where you have low human population density but super high effort. So.
And is there any change in the distance that anglers are willing to travel now?
I think I don't have the data, like individual data, but what I would expect we would see is that local anglers are probably going like closer to home, but we've seen an increasing contribution of non-Canadian anglers, so I assume those folks are probably willing to travel a lot further and go to some of the lodges and places up north.
Thanks.
Yeah, thank you.
Thank you very much. From afar, I've been very impressed with myKatch, the myKatch project in British Columbia. Can you say anything about whether you've incorporated or talked to them about their data and their data collection program?
I'm not super familiar with the myKatch project. I'll have to chat with you about it.
Yep.
Well, it is lunchtime, but yeah, maybe catch Julie afterwards. I think she's been on hook for a while. Cool. Cheers.
Okay, thank you.